About this guy, Edward Muybridge. I'm not sure if it's Edward or Ed Weird. I don't actually know. I'll call him Ed Weird. And he was kind of a freaky dude. He was around in the late 1800s. One of the first people in kind of the West. He was based out of San Francisco, I think, for a lot of the time, kind of the wild, when it was a little bit more of a wild, wild West. He was super interested in early photography. And I don't know if have you guys seen the movie Nope? They play this little gif of the jockey on the horse. And it's real. I don't know if the story behind it is true that they talk about in the movie, but the images are real. This is one of the first kind of sequences, some really kind of rigorous photographic experiments, trying to see if a horse has all four of its feet off of the ground at some point when it's running. Before this point in time, 1887, we genuinely didn't know. We had no way of kind of like slowing down time enough to see what was going on. But this dude, Ed Weird, was really into rigorous photographic studies. And so he would set up multiple cameras. Again, back in the day, this was very manual. It wasn't the push of a button. It was like all of these different really crazy, insane setups for this to happen. And so he did this not just with animals, but also with unfortunate interns, I think, and little G-strings, I think, those poor students. Maybe human rights violation now, but back in the day, this was kind of groundbreaking, rigorous scientific studies of motion. And this was huge. This was a really big deal to be able to take these rigorous images in a scientific way. There's a really great book by Rebecca Solnit about Mr. Ed Weird. She has a theory that this way of thinking about photography emerged at the same time as train travel, like cross-country train travel happened, and that the idea of like sitting on a train and watching space pass by you kind of collapsed or annihilated space and time in an interesting way that then kind of like triggered these thoughts about how we can take multiple images in a sequence. So there's kind of an interesting idea here about how the technology affecting all of us in our ambient lives opens up new kind of portals or avenues for new mediums and new ways of thinking about or exploring the world. And so in the same way that the telephone maybe inspired different forms of media, we can think about the invention of the internet eventually leading to AI and all of that good stuff, and thinking about things in terms of networks instead of sequences. But this is a little earlier in the chain, so this is starting to think about time in a sequence. And this is a really early step along the path to film and making movies. But these quote-unquote chronophotographic studies were big at the end of the 18th century. So at the same time as Mr. Ed Weird, there's also this dude, Jules Etienne Murray, who's doing similar studies, but superimposing images onto each other. So different moments in time superimposed together to get a sense of sequence overlaid into these really compelling, not just photographic studies of motion, but I think also kind of freaky sculptures and statues of the same idea. So a moment drawn out in time and space. So people, animals, starting to think about sequences overlapping and existing in space together. This is kind of an interesting, like, abstracted diagram of a soldier walking. So working with photographs, annotating them, kind of breaking down a sequence into these abstract lines and points that you can then track through space as information about motion. So abstracting experience into something that's not quite real, these are points and lines, but that help us better understand flows and sequences. And these are more examples. I think this one's of a horse. People really wanted to understand how horses were walking around, I guess. And then this was emerging at the same time as like the Cubist movements. So around the time of the First World War, we were also seeing really radical breaks in art and abstract art. And this can be thought of in kind of a direct conversation with the things that were happening in photography and starting to stitch together into movies, thinking about cubism as an understanding of multiple views or perspectives or moments in time superimposed onto each other. So this painting by Duchamp is kind of an example of like, you can see a direct correlation with what Muybridge is doing in the 1880s, then showing up as this kind of like multiple moments in time in his painting Nude Descending a Staircase. So really interesting kind of collision of ideas all exploding at this point in time. There's also people experimenting with different forms of taking images, maybe radical new ways of thinking about what an image is. So Man Ray did a lot of studies with quote-unquote rayographs. I don't remember if these were X-rays or what the deal was with them, but essentially like non-traditional photography, looking at images stacked over each other and then measuring almost like an X-ray or what's the word? Cyanotep kind of effect. And then exploring just like what a single image means, exposed over time. So this is a picture from the 70s by Hiroshi Sugimoto, and it's basically just one long exposure of a movie theater over the duration of a movie. So for the whole 2-hour period or something, the shutter is open, and what it captures is just essentially this mass registration of all of the photons coming from this movie across the screen, which is just an interesting registration of time in a single image. And in the 50s, we also start to see the explosion of really impressive photographic technology. So not only can we take photographs and we can take them in sequence, we can now also take them really, really quickly. And by doing this, we've effectively like slowed time down to this infinitesimal moment. We can zoom in to when a bullet passes through an orange, which may seem kind of banal to us now, but at the time it was kind of massive. We kind of like opened up this new dimension of time. And this also shows up in art in interesting ways. So David Hockney, as a photographer, starts collaging rolls of film together, separate images into sequences that track maybe how a Scrabble game is experienced. So photographing moments through time, collaged together into one image that represent the entirety of this Scrabble game. And it's kind of a beautiful experience, just moving around these individual moments that together piece together really clear understanding and experience. And he does this in a lot of interesting ways. This is what looks like kind of one consistent view of a highway, but it's the same point of view photographed across a whole week in the 80s. So hundreds of photographs across the span of an entire week stitched together into this kind of composite understanding of a place across time. So one image representing this kind of thickness in time, which is really interesting. Portraits of people based on these kinds of like smaller gridded images, also kind of reflecting how the human eye only really kind of picks up one point of focus at a time and zooms around in between these different points of focus. Really interesting approach. And then you'll probably come across these photographs at some point in your architectural career because they're just kind of really beautiful, compelling images of industrial architecture that everyone is always drawn to. But this is a really fascinating study done by Byrne and Hilla Becker of industrial architectural typologies. So they found through studying different industrial sites these re-emerging forms that weren't necessarily like beautiful architecture, but that had a really crazy consistency to them. And through this like really rigorous deployment of photographs, so same angle, same composition, same photographic kind of settings, they're able to compare and create this massive catalog of all of these disparate places in time. So same object spread out through space, but all speaking the same language and doing the same things. So this is a really interesting strategy for yourselves if you're ever studying a typology or a neighborhood even, just really consistent photography using the same language across images to compare and make comparisons between things that are similar is a really great strategy to do so, kind of cataloging image as catalog. And then this is a more modern interpretation of all of their images superimposed onto one another by Idris Khan in the 2000s. So taking those rigorous single images and stitching them together into this one kind of monstrous like composition of all of them at once, you get this understanding of how all of these forms kind of average out into one consistent language. And it kind of looks like a first pass of an AI generated image, which is kind of interesting. The idea of like a composite from individual parts. Here's another example. Kind of spooky, creepy. And then another really amazing use of photography, we might talk about it a little bit more later on, is coming out of forensic architecture's work. Are you guys familiar with forensic architecture? They're kind of a fascinating firm out of Goldsmiths in London, forensic architecture. And they use photography, images, film to reconstruct events. So moments in time, things that have happened. They've really been looking into the genocide in Gaza in a lot of detail. But using kind of architectural tools and language to try to find moments of truth through images and photography. So they'll take images that are publicly available or uploaded to social media or crowdsourced from satellite imagery and stitch them together to try to understand or create some sense of truth or clear narrative or consensus, which is an interesting use of emerging tools. They use a lot of Blender, which is interesting. So they kind of reconstruct from images an understanding of 3D space in tools like Blender, which is quite cool. You can kind of see an example here. That's a little Blender camera view. But kind of thinking about like reverse engineering 3D space from two-dimensional images collaged together from different sources. Super interesting work, really urgent. So yeah, placing those 2D images in a three-dimensional environment is kind of a radical exploration. There's also interesting studies like this one, profiling.is. This is just like an art project someone did maybe last decade, pulling images from the NYPD's surveillance archive, specifically a project, I think it was the demographic department or something. They're essentially just profiling Muslim communities. And these were the photographs that they took in their quote unquote investigation. And nothing ever came out of this entire body of work except for these images of just like quite banal, like normal people living normal lives, which is interesting. But there's like an interesting visual language to surveillance and what they choose to document and include. I think surveillance is an increasingly large part of modern culture, and there's new forms of surveillance all the time. Images are just one part of that. I think there's CCTV footage of almost every corner of the city, publicly available, not publicly available. It exists in all these different places, and it has like a visual language to it, which is interesting, that we're always kind of like dipping in and out of. And then images themselves are kind of an interesting source of data. If you zoom in close enough to any image, they're all made up of individual pixels. So each pixel is essentially just a representation of numbers. So most of the time on a digital screen, it's going to be R, G, and B values coming together to create an individual square of color that when you zoom out far enough gives you the sense of an image. But it always comes back down to this little grid of data, essentially. Every image, when you use a digital camera, it is registering data or a series of numbers and feeding it into your hard drive or storage device. It's not necessarily like registering those individual photons. It is taking a mathematical understanding of the image it's receiving at that time as pixels. And I saw a book when I was in grad school, the New Geographies edition 9, and it had this cover of, I think it was like a waveform or a cloud or something that they had turned into, it's a little pixely, but these dots and dashes. And I got really obsessed with this and ended up using this a lot when I was in school, and played around with a tool in Grasshopper to kind of translate those RGB values into more numeric representations, which was really kind of interesting and something I got a little obsessed with. I used it in a lot of drawings, just ending up like taking images and translating them into dots and dashes or numbers and sequences. So translating those RGB values, those data points, into different kind of graphic representations was something I ended up doing a lot. And I found it quite helpful for translating existing images that were ultimately kind of low res or shitty quality. You can sample them using the image sampler in Grasshopper and then make graphics that feel new, that you have a little more control over, but that are just referencing kind of basic shitty screenshots, essentially. So that's where we're going to go today. We're going to use Grasshopper to build a really quick, short little definition here that will take an image of our choosing, and using the RGB values, the numerical information we can extract out of a single image, and then using that to drive some geometry inside of Grasshopper. So we can have like a tractor curve style effect if we so choose, but you can use this in a whole bunch of different ways. That's where we're going. It's going to be a quick, simple little definition, and then if we have some time, we'll look at populating our drawings with other stuff, possibly from Illustrator, etc. So I'm going to open up Rhino and Grasshopper, and I'll pause for a second if anybody has any questions. This is where we're going. So we'll be able to essentially take an image from whatever source you choose, bring it into Grasshopper, and then translate that geometry into something parametric we can play around with. So I'll start a new file. And first things first, we are going to have to find a reference image that we want to work with. You can choose whatever image you would like. I'm going to image search for a cute puppy. Oh, okay. Which one should I choose? Oh my gosh. Let's do... Oh my god. Let's do this guy. He looks cute. Okay, so you just need to save an image somewhere accessible to you. I'm going to save this guy to my desktop. Okay. I'll pop back into Grasshopper. The main component that we're going to be using, that's really kind of the hinge of this whole operation, is called the image sampler. This one's under parameters, input, and then it should be this little green pixely guy here up at the top called the image sampler. You can also double click and type in image sampler. And it should look something like this once you've got it on your canvas. It's essentially just like a little preview frame, a little placeholder for the picture we're going to feed into it. By default, there's nothing in there, so it'll be this kind of angry red exclamation point with no information. If you hover over the little comment button here, it'll tell you floating parameter image sampler failed to collect data. Basically, we just need to feed it an image for this guy to run. So to load an image, all you have to do is double click on any point on this little image sampler guy. So anywhere in this big square, double clicking will open up the settings dialog here, image sampler settings. And from here, there's a little option down here called file path. So a little empty box where we can link to our image. Usually the easiest thing to do is to click the little dot, dot, dot beside file path. So I'm going to click the dot, 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 and I can navigate to wherever I have my cute puppy saved. Mine's on my desktop. So again, just click the little dot, 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 find your pic. And you should, when it's successfully loaded, you should see your little guy previewed in this kind of grid off to the left-hand side. We're going to ignore the stuff at the top talking about domain for now, but just note that right now you can see it's going on the left-hand side, top, right-hand side, and bottom. There's these little numbers going from 0 to 1 in the X and Y direction. We'll come back to that one in a second, but just note that that's there. The only other real settings to take a look at with the image sampler is the channel. So underneath all of this domain stuff, you can see that there is different channels of information you can pull out of your image. So this is essentially choosing which numbers or data that you're interested about this picture. By default, it's going to be set to the RGB value, RGBA, A just being like transparency. But there's also, you can isolate the red data, green data, blue data. Alpha channel is transparent or not transparent, so this only really works with PNGs. Color hue, color saturation, and then I tend to use this one a lot. I use color brightness a lot. So I'm gonna set my channel to color brightness right now. And this one's nice because it's just a number value between 0 and 1. 1 being totally bright, it's basically white. 0 being totally dark, basically black. And any number between 0 and 1, talking about this gradient from dark to light. So we've got our image, we've set it to darkness or color brightness. I'm gonna hit OK. When it's loaded in, you should see a cute little black and white pic of your little guy that you've chosen. And you can see there's nothing really coming out of the right-hand side. Like if I look at a little panel, there's nothing coming out of my image sampler yet. There's no information here. And if you hover over this little warning sign, it'll say image sampler failed to collect data. So we need to feed it some sort of data in order for this component to really run properly. And essentially what it's asking for, what we have to feed it, it knows that we have this image, it understands that there's 1 million pixels, but it wants to know which pixels you're interested in. So we need to tell it where exactly on the image to look. So where on this little guy, where do we care about? And it needs that in point form. So we need to feed it some points to sample and read the pixel at that point in space. So for now, we can grab a little placeholder for this. We just want to generate a point to see, kind of zoom around and see what we're getting out the other side. So I'm going to build a point really quickly in Grasshopper using what is called the MD slider. So under parameters, input, I'm going to grab MD slider, multi-dimensional slider. The icon is a red arrow and a blue arrow. And it looks something like this. It's kind of a crazy little input here. But this essentially creates a nice little floating point inside of Rhino or Grasshopper space. And this is just a really quick way to construct a point between 0 and 1. And you can grab that little dot and slide it around this axis. And it'll just create an imaginary point at this spot you've defined. So if we plug this MD slider, again, MD for multi-dimensional slider, if we plug this one into our image sampler, you can see what we're getting out the other side is 1 value. So for me, that number is between 0 and 1. And if I play around with my MD slider, you can see that that value is changing. So if I move it around to somewhere in the image, maybe in the bottom left-hand corner where it's kind of pretty bright. So that's this point. If it's in the bottom left-hand down here, it's probably somewhere around here in my image. You can see the value is 0.74. So it's in the upper 3/4 of brightness. Whereas if I drag it around maybe somewhere near the middle, near his nose perhaps, you can see that number gets really small. So on the spectrum from darkness to lightness, darkness is going to be down at the 0 end of the spectrum and brightness up near the 1. So a value of 0.32 is probably somewhere in here. And our little dot maybe is somewhere around his little nose or eye. So essentially what we're learning is that whatever points you feed into the image sampler, it's going to spit out the brightness value at that specific point. And this works quite nicely because when you bring in an image into the image sampler, as we mentioned before, it thinks about that image in a domain from 0 to 1. So it thinks about this image in space. It doesn't actually know much about the size of it. But if this is my picture of this is my picture of my little guy, it thinks about it in this kind of dimensionless way from 0 to 1 in the x direction, and then from 0 to 1 in the y direction. So it's this kind of like imaginary grid that we've split up our little guy into. And then from here, any point between 0 and 1 in x or y direction we'll be able to map onto our little fella. So essentially I want to create a nice little grid of points on top of my picture. Right now it's not super helpful to have just a single dot, a little pixel floating around on top of this image. I want to create a nice rigorous grid that we can use to sample points at various spots across this image to start to control what points we're interested in a more systematic way. So first things first, I'm going to create a grid of points. I'm going to get rid of my little MD slider. I don't really need her anymore. So I'll hit delete. And you'll remember from our attractor class last time that a nice easy way to make a grid is always under the vector tab. So under vector and then grid, you can choose your adventure for which type of grid you want to work with. I'm going to use a square grid for now. You can also just double click and type in square and grab the first option that comes up there. Again, by default, this is going to start making a tiny little grid down at your origin for you. And by default, it's already making a 5x5 grid with a cell size of 1. We can plug this into our image sampler if we want. And we'll start getting some values. But it's not very consistent or clear where these points are relative to our little image. So if our image is going from 0 to 1, we're thinking about our image from 0 to 1. But our points exist in space in dimensions that are much bigger than 0 to 1. We have to go back and start to rethink about how we can think about or tell Grasshopper about the dimensions of our grid. So instead of directly using these points, I'm going to use a little workaround instead. I'm going to turn these points, this grid of points, into one big flat surface. Anytime you have a surface inside of Grasshopper, Grasshopper likes to think about surfaces in terms of what's called a parameter. So regardless of how big that surface is, maybe it's like 700 units in the X direction and 500 units in the Y. Oh my goodness. Grasshopper will always let you think about, kind of regardless of this dimension, it'll always let you think about the points along that surface in a range from 0 to 1. So regardless of how big it is, you can always have the option to tell Grasshopper, okay, actually, I don't care how big it is. I just want to think about it in relative terms. From the bottom left-hand corner, it's going to be 0. That's our kind of 0, 0 starting point. And all the way over on the right-hand side, it's going to be 1. And ditto, top left corner is going to be 1. Top right-hand corner is going to be 1. So we can think about this surface regardless of actual dimension. We can think about it in these kind of theoretical values between 0 and 1. And that's going to let us map really nicely onto our picture. So regardless of the size of our little puppy here, we also can think about him, the picture of this little guy, from 0 to 1, 0 to 1, regardless of the size of the image. So we're just kind of like abstracting our grid. We're thinking about it in slightly different abstract terms. Does that make sense as an idea? It's a little bit confusing, but it'll make more sense in a second. So basically, we need to take these points that we have and turn them into this kind of abstract surface from 0 to 1. So I'm going to grab all of my points, and a quick way to make a nice flat rectangular surface from a grid of points is going to be using a bounding box component. Bounding box. This one's under surface, primitive, and then bounding box. And this one, essentially, you can tell from the little icon for it, you can feed it a whole bunch of points, and it'll give you the smallest possible box envelope around those points. So in this case, if we feed it a nice flat sheet of points, it'll give us a nice flat sheet. But there's one little thing to note before we start feeding our points into it, and that's if you zoom in on the component, there's a little tab that pops out of the bottom here. And right now it says per object. And what this means is essentially it's asking you when you want to create a bounding box. If you want to create a bounding box, so the smallest possible envelope around each individual object you feed it. So do you want the smallest box possible around each point? Or do you want a box around everything that you feed into this whole thing? So collapsing the whole list of points and creating one big box or envelope around everything. So right now when it's set to per object, this little tab down at the bottom here, that's telling me it's only going to draw a bounding box around each individual point. That's not what we want. We want to be able to make a nice flat sheet out of everything. So to change this from per object, we can right click on bounding box and choose this other option instead called union box. So we'll right click and come down to union box. This is nice. This is going to give us a nice clean unified output. So just one box around everything that we feed it. And now I can come back to my grid of points, feed points into content. The content that we want to contain or draw a box around is our points. So points goes into content. But you can see if I click on my little bounding box, what's happening in Grasshopper space, I suddenly have these thin lines being drawn. So instead of a nice flat surface around everything, I'm ending up with these individual strips or boxes around rows of points instead of the whole thing. Can anybody guess why or what we need to do to fix this? This line here is dashed as a bit of a clue. So right now our points are existing in their own branches of information. So if we come and look at each point here, you can see they're grouped in little chunks. So this dark bar indicates just a separation between branches or groups of data. So right now Grasshopper is thinking about each point kind of within a row. So each row exists on its own branch of information. So when we go to draw a bounding box around them, Grasshopper is thinking, okay, you care about these points in their individual rows, so I'll just make a bounding box around each row. But since we care about the whole thing, we don't want any of these separations or branches of information in between them. We want them to just think about the whole thing at once. So we have to come back to our initial points here, and exactly the same as we did for the attractor points. We want to flatten the data structure. So get rid of all of these separations or splitting into rows. So I'm going to right click where it says points, right click on points, and choose flatten. Right click and then flatten, the little down arrow. So you should see a little down arrow next to your points. Now all of my coordinates are on one big flat list. There's no separation in between them. And so my bounding box component is just drawing one nice clean box around my entire grid. And this is nice because it's all parametric. So if we change the number of squares in each dimension, if I come back up to my square grid and plug in a different number slider, so maybe I want actually 15 squares in the X dimension, my bounding box will automatically update. So the nice surface, it'll create a nice little surface around all of the points in my grid, regardless of how big that grid gets. So I can play with this slider and it auto updates that surface. And the point of making this nice little surface was in order to be able to think about these points a little bit differently. So instead of mapping them in space, where we have all of their coordinates, and these coordinates are quite big numbers in space, we want to be able to think about them from 0 to 1. So we can take this nice little surface that we've made and use a sneaky little component workaround to figure out where these points are, our initial points are, on this surface from 0 to 1. So kind of translating these point values into a number from 0 to 1. And we can do that using a component called surface closest point. Surface closest point. And what this one does is essentially it takes any surface that you feed it. So we're going to feed our bounding box into surface. And then any list of points that you feed it, we're going to feed our original grid into here. And it essentially just grabs our reference point on the surface that mimics or is closest to the original point that you feed it. And the reason we're doing all of this kind of annoying extra workaround is to get this nice little output here, the UV point. And UV, if you've ever done any kind of texture mapping or anything in for rendering purposes, a UV essentially is a different way of thinking about a surface. And this essentially means the same thing as our interest in going from 0 to 1. Anytime you have a complex surface, maybe like a sphere or something, and you want to do some texture mapping or something on top of it, you have to kind of unwrap that surface and flatten it out first so that you end up with your whatever nice flat surface. You've unrolled it from 3D space into 2D space. And so modeling spaces think about the dimensions of that surface in terms of u and v. So instead of the x direction and the y direction, because our original surface maybe exists somewhere kind of wacky and contorted in x and y space, u and v is just a kind of different language or way of thinking about the two dimensions of that flat surface. So as it goes from 0 to 1 and then 0 to 1 in the relative kind of x and y direction, we just call that u and v when we're thinking about a surface. So all that to say, if that doesn't really make any sense, that's okay. We're basically just interested in getting the UV point on that surface, because that'll map really cleanly onto our image, regardless of the size of the image, regardless of the size of our grid. This is a nice little workaround to make sure that we're getting a nice, clean mapping of points onto our image. If we don't do this, it's unclear how big the image is. Sometimes it brings it in really big, sometimes really small. It's just really tough to map a nice grid onto this imaginary picture. So in order to get these UV points, in order to translate this grid of points nicely onto my surface, I'm going to plug in my bounding box, so my nice flat plane. I'm going to plug that one into surface, on surface closest point. And then I'll come back to my grid of points that we started with here and plug points from square into point on surface closest point. And what you should see is a whole new grid of points popping up here. And what we're really after is this nice little UV point here. But these numbers right out the gate aren't necessarily thinking from 0 to 1, which is annoying. Since our surface exists in bigger dimensions than 0 to 1, we have to take one little extra step to force the surface to kind of like clear its memory of how big it is. So right now it's thinking of it from 0 to 10. We just have to prompt it, okay, forget that, forget how big your initial dimensions might be, and think about it from 0 to 1. And we can do that using another little sneaky command in Grasshopper. Again, by right-clicking on one of your inputs. In this case, we're going to zoom in on surface closest point. We'll right-click on this one and hit reparameterize. So reparameterize essentially forces Grasshopper to think about the surface, regardless of how big it is, any surface, from 0 to 1. So you can see now these numbers exist somewhere between 0 and 1. Every single value exists between 0 and 1. Whereas before we hit reparameterize, all of these numbers are quite large and just depend on the size of the initial surface. Reparameterize forces it to think about this range from 0 to 1. If this doesn't make sense, that's okay. This definition is really flexible, so once you have it built once, you'll be able to change the image in here really easily without much effort, and without having to ever think about reparameterizing your surface ever again. But just know that that's kind of what's going on in the background. We need to map these points into a language that this image sampler understands. So we've got this great grid of points running from 0 to 1 that is mapping in our Rhino space in whatever dimensions we choose. So I can make this grid really big. I can change the size of each cell if I want. So I can make each cell 5 units big. And regardless of what's happening here, all of the values coming out of my UV point will be somewhere between 0 and 1. So no matter what you change, it will always play nicely with the image that we're working with. So now I can come back to my little image sampler component here. And now we have these great UV points that will map really nicely onto my picture. I can take UV point, so the output of UV point, and plug that one straight into our image sampler, replace whatever was there before. And you'll end up with the same thing you had before, so just a list of brightness values between 0 and 1. But now these are mapped in space quite nicely and cleanly to our image. We can take these values and start to play with them with some geometry in space. So maybe I want to draw some circles, kind of similar to our attractor point definition earlier. I want to draw some circles, and then the size of that circle can represent these brightness or darkness values. So I can grab another circle component. Again, you just need to feed it a plane. So where do you want that circle in space? And then a radius. The plane we have, so we have all of our nice UV points. We can plug those into plane on circle. By default, it's going to be drawing a circle, a tiny little baby circle. I think however many units big. Actually, maybe it's better, instead of using the UV point, we can use the point output there. I think it was getting a little confused with the surface versus circle. So I'm just going to actually change that up from UV point to point. And then for the radius, we can grab the output of our image sampler and feed that into radius. And you can see it should be drawing a little grid of circles based on the brightness values of your image. It's a little hard to tell right now, so I'm going to turn off everything that comes before circle. So I'll grab all of these components, right click, and hit preview off. And I'm left with this varying grid of points. Right now it's a little hard to tell if or how it's mapping to my image. So I'm going to play around with the density of points. So maybe I want to work with a bigger grid. I'll increase the extent in the X and Y direction. And maybe decrease the size of each cell. And now you can start to see that image come into view. So the bigger the value, the bigger the circle. So the brighter the pixel, the bigger the circle we end up with. You can start to see our little puppy guy showing up. And then from here, same as our attractor point example, we can also play around with the values a little bit. So maybe instead I want to have my brightest values be the smallest little circle, and the darkest spots in my image have the largest or most big visual impact. So I'm going to take these values and I want to flip them and reverse them, so I can take the inverse of each one of these. Or is that a reciprocal? I don't know. I haven't done math in 10 years. So we're going to use a component called 1 over x. 1 over x. And this just lets you get the inverse of each one of these little values that we plug in. So if I plug in my nice list here, you can see what comes out the other side is those values flipped and reversed. So now the smaller the value, the bigger our number is going to be over on the right-hand side. I can plug this into radius on circle. And she's definitely too big. We're getting numbers that are way too big. So this could be another case for remapping numbers like we did with our attractor point or curve. Remap numbers. We can do this one again. Or I'm just going to play with my grid until it looks okay. So I'm going to make the size of each one of these little cells a little bit bigger. Oh, he looks insane. But you can see what it's doing. The darker spots on the image are coming in as much bigger circles. So this is probably going to be a good case for remapping those numbers. Again, you just need the value, the bounds, and then the target domain by default will be 0 to 1. So that should play quite nicely with our radius of circles. I'll make my little grid smaller again. And by playing with the domain or the bounds of that, the possible values that we're playing around with, you can end up with a more high def or clear range of circle sizes. So right now you can just see his poor haunted little eyes and his nose and this little dark spot over on the right hand side. But by adjusting the domain values, so the smallest possible circle size and the biggest possible circle size, you can build a more precise image. Last time we did that through construct domain. Domain goes into target, and then start and end are things you can control. So playing around with number sliders is always kind of the best way to hone in on the scale that you're interested in. The real trick is making it look less scary in this instance. But this is a really useful toolkit to play around with, so I can come back in and change this picture to whatever I want it to be. I use this a lot with maps, so if you grab like a climate change heat map, you can grab any one of these values. Maybe I want something that's a little more like brightness and darkness coded. So I can save this image. And replace my cute puppy with something more depressing. Oh, where'd it go? Hot oceans. And now you have kind of a visual representation of that image you've plugged in. So anything you feed into it can then be turned into dots, a grid of dots. It doesn't have to be circles that you're representing this with. It can be any sort of information that you like. So I got into translating the numerical values here into essentially like what was represented on the screen. So you can map these directly onto the image if you're interested. You can turn these into 3D geometry, so extruding. By these values. Oop, unit Z. This kind of ends up looking like Daniel's drawing. But there's a whole bunch of different ways that these values can then feed into the image outputs that you're working with. Does anybody have any questions about that one? One last thing I think we'll touch on for today. I'll just show you about moving in between Illustrator and Grasshopper and Rhino. This is also something I did a lot and found quite interesting when I was in school. Was taking things that were maybe more loosely drawn in Illustrator, not necessarily drafted, and then bringing them into Grasshopper to play around with. So I found this really helpful for populating drawings. Maybe you have like a field or a forest or something. It worked really well with plant style drawings. But you can take anything that you've drawn in Illustrator, move it into Grasshopper, and then do all kinds of transformations and effects with it. I'll use my number slider as kind of a base for drawing maybe like a two-dimensional scene of some plants. So I'm gonna draw a quick little flower. My favorite way to draw stuff in Illustrator was using the pencil tool, which you can get to just by pressing N at any time. It's also in the little drop down from the paintbrush tool on the left hand side here. So the pencil tool is kind of nice. It just lets you like freeform draw anything in Illustrator. But there's some nice settings that come along with it that I found quite helpful for getting control over what you're scribbling with. So anytime you have the pencil tool selected in Illustrator, again, just by pressing N, there's a little button here that says Tool Options, Options for selected tool. And this little slider gives you a lot of control over what your pencil strokes are gonna look like. So if I change this slider all the way down to accurate and hit OK, when I use the pencil tool and it's kind of janky, scribbly, it'll really stay that way when you have it set to accurate. It won't smooth out any of your geometry and you'll get something very close to like what you've actually drawn. But if you come to tool options and then slide it all the way to smooth, this will do the opposite. It will take anything kind of janky, weird that you feed it and do its best to try to smooth it out into some nice, smooth geometry. So you can see what I've drawn initially maybe is a little bit annoying or jumpy, and then it gives me kind of a nice, like, smooth, interpolated version afterwards, which can be kind of helpful. So I liked the pencil tool just to draw, like, I don't know, little plants and stuff. Maybe I'll draw a quick little flower. Beautiful. It's not really much of a flower. Oh well. Okay, so I have a nice, cute plant in Illustrator. I'll make it green. And sometimes back in the day, I don't know if this is still true, it only works like 10% of the time. You used to be able to grab something you'd drawn in Illustrator, hit Control-C, move into Rhino, and then hit Control-V, and it would paste it. Oh, it worked for me today. So this is incredible. You can move from one to the other seamlessly with just Control-C and then Control-V, and it'll bring in the geometry for you. It is a little less smart with fills. Like, I think if this was a filled object, I'm not super sure how it would handle it. Sometimes it brings it in as like a solid hatch. Depending on what you're interested in, this could be helpful or not. So you can see that solid fill comes in as a hatched object, separate from the curve. But this is a really quick way to move in between if you're like sketching stuff in Illustrator. Maybe this is a different plant. Yikes. You can bring in a couple different types of geometry really quickly. And then using Grasshopper, you can take these drawings and make them go crazy however you like. So maybe I'm going to use my my little image sampler here. This since I already have a nice grid of points, I can make my little plant show up at every spot on that grid. So I can kind of populate my plant into essentially a field condition. I'm going to make it smaller first so that it'll fit on this grid a little more nicely. But you can bring any geometry into Grasshopper very easily using a nice little geometry node. So coming back into Grasshopper, I can double click and type in geometry and grab one of these empty little containers, so a black hexagon. This one is under params geometry, and it's just this empty little container guy up at the top, or actually down at the bottom, a little swirl. I can right click on this one and choose set one geometry. Grab my little guy, and now I have my Illustrator drawing linked into Grasshopper. I can take this geometry and essentially move it to every single spot on my little grid. So if I want to have a whole field condition of this plant, I can move it over to every single spot on this grid using the move component. The geometry I want to move is my nice little plant fella. So I can grab my geometry node and plug that into geometry. And then I just have to figure out the motion that I want to create. So by default, it's taking my plant and moving it upwards by 10 units. That's not quite what we're interested in. We want to grab this plant and essentially plant it at every spot on my grid. The point I want to move to is essentially what's coming out of my initial square grid component here. So every little spot on this grid, I can plant a little plant. That's the point I want to move to. We need to feed the move component a quote-unquote translation vector. So basically what it needs is it needs to tell you where it's moving from and then where it's moving to. So basically from point A to point B, and it's asking for this arrow in between. Where are you moving from? Where are you moving to? This arrow in between, that's going to be our translation vector that goes into motion. And the easiest way to build that is under the vector tab, vector, and then vector, and then this nice easy little component vector to point. So this will create a nice little, it'll make that nice line between our point A, so the point you're starting from, that's an A, oops, and point B, the point you want to move to. So A to B, and then it'll make this nice little arrow in between. So the points we want to move to, the point B, we know where we want to move on our grid. So I can plug points from my initial square grid into point B. That's where we want to end up or move to. And then we just have to figure out where to move from. So point A, where do we want to move our plant from? Essentially, where do we want to plant it in the ground at that point? For me, I want to plant my plant right down at the bottom of its stem here. So I can come to point A, right click, and choose set one point. This is kind of a nice little quick way to do it. You could be more strategic and build a physical point that moves around with your geometry, but we'll save that for another day. So I hit set one point. I can just click right down at the base of my little stem here. And so you can see what it ends up doing is building a line between that little base point on my plant. You can see my base point and all of the points on my grid. if you ever want to visualize or see what your vectors are doing or kind of what you're building, you can come over to the display tab. Because by default, it's not going to show you a vector. A vector isn't something that necessarily like exists physically. It's more of a instruction. But we can come over to the display tab up at the top, and then there's a whole bunch of different vector options for displaying what these directional lines might look like. So you can use vector display to illustrate to you where your lines are moving from and then moving to. So vector display, you can see what I end up with here is this massive, massive list of lines here moving from my starting point to all of my little endpoints. So it's pretty dense. I'm not sure we're going to see much. That's just a little visual if you're interested. But otherwise, we're good to go. We're ready to move our plant. I think I'm looking at it upside down. Yeehaw. There we go. We can move our plant to every spot on our grid by plugging vector from vector 2-point into motion on move. It might chug for 3 days, depending on how big your grid is. But you can see what we end up with is a big clump of my nice little plant. You can see it's made a whole bunch of copies at every single spot on my grid. Right now it's a little bit too big to tell what's going on, so maybe I will scale down my initial geometry. It should be live linked. So any changes I make to my initial guy will percolate through my drawing. So if I scale him down, now my grid of plants should be a little bit smaller. You can start to see it show up there. Maybe I'll also make my grid a little bit bigger. I'll space these guys out a little more. So I'll bump up the size of each cell. And maybe I'll decrease the number of points in my grid. It's just a little too heavy for my computer. So I'll drag down the extent to something smaller. And then I end up with something a little bit more reasonable. You can see I've got a nice field condition of my plant. And this isn't necessarily a point you would want to stop at here. But you can take these individual objects that you've created and start to apply some randomness in here. Maybe you flip some of them at random. Maybe you take the values from your image sampler output earlier on. So this nice list of numbers. We can use that to scale each one of our little plants. So I can grab a scale component and scale every one of my little plant copies here by a factor that comes out of our image sampler. And then you end up with more of like a field condition. Right now it's scaling all of them by a center point at 0, 0, but if you want to scale each one around its own root, you just have to change the factor to our starting grid points. And then the scale of each plant will kind of match to that image that we plugged into our image sampler. But you can use any sort of geometry or data to drive scale, rotation, anything of that nature. And the beauty is the live linking. So if you make any changes to your initial geometry, so if I come in and make this guy really tall or wacky for some reason, it'll percolate through my nice drawing. All of those copies will automatically update. So this is a great way to draw landscapes, forests, all that good stuff. And the same thing applies to 3D geometry. So you can populate a scene with 3D models very quickly, and then use scale. Rotate is another great component that takes very few inputs, and rotate them either by values that you have or by random numbers. You can always generate a random list of numbers using a random component to feed in to control the size, scale, rotation of any of your objects that you've copied over. And it's really easy to use this one definition for a whole bunch of different items. So I can come in and draw a completely different shape in Illustrator, bring it back into Rhino, replace this initial geometry, and it'll percolate through my drawing. So it's just kind of a nice live way to build up more complex images. I ended up doing that a lot in school, especially for making, I don't know if I have any examples here. Beep boop. These kinds of images, like a lot of the plant life was just kind of drawn once and then manipulated or rotated in Grasshopper and percolated across a kind of field condition. So definitely useful. Something that is really helpful if you ever find yourself drawing repetitive objects or populating a scene. Something I come back to a lot. So I'll stop there. Do let me know if you have any questions. Otherwise, we will hop into After Effects this Friday, so make sure that you check out Creative Cloud. When it's loaded and updated, you should be able to come down to Apps and add in Miss After Effects into your installed apps. I thought I had her installed, maybe I don't. So install After Effects. You don't need to include Cinema 4D by Maxon. You can if you want, but that's a whole other ball of worms that we're not going to get into in this class. Cinema 4D is kind of like a animation rendering engine in 3 dimensions. But this is what we're going to jump into on Friday. I'll stop there. Unless anybody has any questions, I'll stick around, but I'll see you on Friday.